Hello everyone. Today we'll discuss about the basicity of aromatic amines. Lastly, we have discussed the comparison of basic strength among primary, secondary and tertiary amines in aliphatic amines, right? Now today we'll shift to aromatic amines. So first we have one very important comparison of aromatic and aliphatic amines regarding their basic character. I have taken two examples here. One is ethylamine and one is aniline. If you see ethylamine, the value for pKb is 3.29 and for aniline it is 9.38, right? So higher the value of pKb, which shows that it's a weaker base, it's a stronger base as compared to aniline. And you see, moreover, the difference in the value is too large, which shows that aniline is a very weak base as compared to ethylamine. Fine. So in general we can say when nitrogen is directly linked to the benzene ring, that is in aromatic amines, the basic strength is too less as compared to aliphatic amines, right? Let's discuss the reason behind it. If we see on the reactant side, then there is one factor, that is plus I effect of the ethyl group, which increases electron density present on the nitrogen. So more electron density on nitrogen, more will be the attack of H positive, easy will be its attack, so it have more tendency to gain H plus. Fine. Moreover, if you see the product formed in this case, nitrogen having positive charge with 4 bonds, then this plus I effect of ethyl group is going to stabilize nitrogen by releasing electron towards electron deficient nitrogen, right? So this stabilizes the cation formed also. Fine. So both the factors are favorable, which shows that it's a stronger base. Let's discuss aniline now. After the attack of H plus, the cation formed is this, right? Now here nitrogen have already formed its 4, that is maximum 4 bonds. So further the only possibility of the contributing structure is the calculus structure for this. These are the only resonating structures formed for this particular cation, because nitrogen is already in the maximum covalency. Fine. So if you see these two structures, then only the pi electrons are delocalized, but there is no change in the plus charge on the nitrogen. There is nothing which is going to stabilize the positive charge on nitrogen. Its electron deficiency still remain as such. So this shows that this is a very less stable cation. So that means the attack of H plus towards aniline is very slow. It shows that it's a weaker base. Moreover, one more effective reason we can put up here. In this case, if we just see the resonating structures of aniline, then you see here it is n electrons and pi electron. Due to n pi conjugation, we have shifting of electron. If you observe the structure, nitrogen is having a positive charge, double bond here, and negative charge in the ring. And you know the nature of the ring, negative charge goes on delocalizing in the ring. As a result, you see here that in all these structures of aniline, there is present positive charge on nitrogen, which shows that nitrogen is electron deficient in nature when a benzene ring is directly attached to it. Or in other words, you can say that availability of lone pair on nitrogen is less as compared to in case of ethylamine. This is due to presence of resonance, as nitrogen is directly linked to the benzene ring, right? So because of this effect, if you combine all these structures, that will give you resonance hybrid of aniline, then you will see that there will be presence of electron deficiency on nitrogen, which shows that it's a weaker base as compared to ethylamine. So this is a comparison. We have found that aromatic amines are less basic as compared to aliphatic amines. Fine. Now let's further discuss what is the effect of substituents present on the benzene ring in case of aniline, what is the effect on the basic strength? So we have certain comparisons here. Relative basic strength of substituted aniline. Fine. So we know the basic here that more the availability of electron pair on the nitrogen, more will be the basic strength of aniline. Fine. So you see, if substituents present are electron donating group or electron releasing groups present on the ring, I am not mentioning a particular position here, that we'll discuss later, then you see these are electron donating. So as a result, when the ring becomes more negative, it will have a less tendency to attract the lone pair present on nitrogen. As a result, the electrons are more available on nitrogen. Fine. And moreover, if you see after attack of H+, if you see on the product side the cation form, that is this, which is electron deficient. So these groups, if present, electron donating group, they are going to stabilize it, stabilize the cation. So as a result, if these groups are present in the ring in case of aniline, then they are going to increase the basic strength of aniline. Fine. So we have groups like alkyl groups present. So these alkyl groups are going to increase electron density on nitrogen. As a result, the basic strength is more as compared to aniline, right? So this is one. Next, if the substituent present on aniline is electron withdrawing group like NO2 group, like cyanide group, like aldehyde group, etc. Now these groups have a tendency to attract the electron towards itself. As a result, they will make this ring as more electron deficient. As a result, a ring have more tendency to attract these electrons towards itself. As a result, the availability of lone pair on nitrogen is going to decrease. And moreover, let's see the stability of cation formed in this case. Then you will find the cation is unstable due to presence of electron deficiency on nitrogen. And moreover, if these groups are present, they are further going to decrease the electron density on nitrogen. As a result, they will make this ion more unstable. So we have found in general that if alkyl groups are present, it is going to increase the basic strength of aniline, and if electron withdrawing groups are present, then they are going to decrease the basic strength of aniline. Fine. Now let's further discuss the effect of these substituents present on the particular positions of the benzene ring, that is ortho, para and meta positions. Fine. So we have found, let's discuss first case of electron donating substituents, say effect of methyl group. We have found here one comparison that methyl group present at para position is going to increase the electron density on the nitrogen, and the effect is too much as compared to ortho and meta position. So let's see what is the comparison here. We have this para-methyl aniline is more basic than meta-methyl aniline, which is more basic than aniline, which is more basic than, this is surprising, that a substituent present is electron donating, but if it is present at ortho position, its effect is very less to increase the electron density, and moreover due to effect called, we'll discuss it, that is ortho effect, this is exceptionally less. This is one exception here, that is